Okay, so today we are going over how to solve systems of equations using the elimination method. So just a reminder from last week, you should be working the problem out and then watching how I do it. So pausing the video, working the problem, seeing how I did it. And then you can always work with the people around you to work through any mistakes you've made if you cannot figure it out from the video. But make sure you are actually trying to do it that way and trying to do something productive instead of just kind of wasting your time and not really learning how to do these, because this is what your test is over on Friday. So we are going to go ahead and jump right in here. So when you have the elimination method, you want to first look for things that have the same numbers. Okay, so what that means is you're going to start with your x's and see if any of them have the same coefficient, which here on number 1, I have 2x and 3x. So those aren't going to be really easy to work with. But I do have 2y and 2y. So looking at that, I have a positive 2 and a negative 2. So I know if I want those to equal 0, I can add them together because they're opposites of each other. So I'm going to add these systems together. And I'm going to do 2x plus 3x, which gives me 5x. 2y plus negative 2y, which is going to give me 0, so I'm not going to have a y anymore. And then negative 2 plus 12, which is going to give me 10. So I've got 5x is equal to 10. I'm going to go ahead and divide by 5 on both sides. So I know now that x is equal to 2. So from here, all I have to do is plug that into one of the equations, and I'm just going to use the top one here. So I'm going to have 2 times 2 plus 2y is equal to negative 2. So I'm going to have 4 plus 2y is equal to negative 2. And that's a two-step equation. So I'm going to go ahead and solve that. So the first thing I'm going to do is add or subtract my constant. So here I'm going to be subtracting it since it is a positive 4. And that's going to give me 2y is equal to negative 6. And now I'm going to go ahead and divide by my coefficient. So my coefficient here is 2. So I'm going to divide by 2. And that's going to give me y is equal to negative 3. And as always, we're going to write our answer as that coordinate point. So I've got an x of 2 and a y of negative 3 for my answer. Okay, so looking here at number 2, I'm going to do the same thing. So right off the bat, I see that my x's are a positive 2 and a negative 2. So those are opposites of each other, which is what we're looking for. So I'm going to go ahead and use those. Now once again, I'm going to add these together. And so 2 plus negative 2 is going to give me 0. Negative 2 plus positive 4 is going to give me positive 2. And remember, I just keep the y. And 0 plus negative 2 is going to be negative 2. So from here, I have a one-step equation. So I'm going to go ahead and divide by my coefficient. And I'm going to get y is equal to negative 1. So then I'm just going to use this top equation right here, where I've got 2x minus 2 times negative 1 is equal to 0. So I've got 2x minus negative 2 is equal to 0. So remember here, I can actually change this to plus positive 2. So I'm going to rewrite that to 2x plus 2 is equal to 0. I'm going to go ahead and subtract 2 from both sides to get rid of that constant because I'm solving a two-step equation now. And I'm going to get 2x is equal to negative 2. And then I'm going to go ahead and divide by my coefficient. So I'm going to get x is equal to negative 1. So then we write our coordinate pair up here, starting with x, which is negative 1, followed by y, which is also negative 1. So we are going to look at number 3 now. So once again, looking for anything that is the same. So here I have x and x, and then I have negative y and positive y. So really, either way I choose to go here, I can use x or y. But sticking with that theme, I'm going to go ahead and choose the ones that are opposite of each other, just so we can kind of keep going down that path we've been going. And I'm going to add these systems together. So I'm going to have x plus x, which is 2x, negative y plus positive y, which is 0, and then 1 plus 3, which is going to give me 4. So from here, I'm going to go ahead and divide by 2 on both sides, and I'm going to get that x is equal to 2. So from here, I'm going to just use this top equation, and I'm going to have 2 minus y is equal to 1. I'm going to subtract 2 from both sides, and I'm going to get negative y is equal to negative 1. And then to get rid of this negative, I'm going to divide by negative 1 on both sides. And I'm going to get y is equal to 1. And then I'm going to write my answer as an ordered pair. So I'm going to take that 2 I got for x and that 1 I got for y to write my ordered pair. So here on number 4, looking for things that are opposites of each other, I don't really have any. But if you look, I do have a 6x and a 6x. So what I'm going to do here is I know that 6x minus 6x is going to be 0. So I'm actually going to subtract these equations. So here, I've got 6x minus 6x, which is 0, 5 minus negative 7y, which minus negative 7 is going to actually give me plus positive 7. So I'm going to get 12y. And then 4 minus negative 20 is going to actually be 4 plus positive 20. So I'm going to get 12y is equal to 24. And then I'm going to solve this one-step equation to get y is equal to 2. And then I am just going to use this top equation right here to solve for x. So I'm going to have 6x plus 5 times 2 is equal to 4. So I've got 6x plus 10 is equal to 4. I'm going to go ahead and subtract that constant on both sides to get 6x is equal to negative 6. I'm going to divide by 6 on both sides, and I'm going to get x is equal to negative 1. So then I'm going to come up here and write my ordered pair as negative 1, comma, 2. So this one you are doing the exact same way, only we used subtraction on the two systems instead of addition, because instead of having opposites, we actually had 2 of the same term right here and right here. So looking at number 5, I've got 2x and 4x. Those aren't the same, but I do have a nice little set of opposites right here at negative 3y and positive 3y. So we are going to go ahead and add these together. So 2x plus 4x is going to give me 6x. And then negative 3 plus positive 3 will give me 0. And negative 6 plus 24 gives me 18. So I'm going to divide both sides by 6 to get x is equal to 3. And then I'm going to use this top equation up here, and I'm going to go ahead and do 2 times 3 minus 3y is equal to negative 6. So I've got 6 minus 3y is equal to negative 6. I'm going to subtract 6 from both sides to get negative 3y is equal to negative 12. And from here, I'm going to divide by negative 3 on both sides to get y is equal to 4. So from here, I write my answer as that ordered pair. So I've got an x of 3, a y of 4, and that is your answer. So looking at number 6, we're going to have to work this one a little differently because there are no two things there that are the same. But there are things that share common multiples. So this is where you are going to want to think back to your times tables, to that kind of stuff that you learned in elementary school. So you want to think of the greatest common multiple. And the easiest way to do these is if you have one, or you have a term that just has 1 as the coefficient, like this x right here, you want to go ahead and start with that one. So I know that I want that x that I just highlighted and this 3x to ultimately end up as being the same term. So what I'm going to do is figure out what I need to multiply 1x by to get 3x. And so that's going to be 3 because 1 times 3 is 3. And I'm going to multiply this entire bottom equation by 3. So I'm going to have a whole new system now, and I'm going to still have 3x plus 2y is equal to 0. But now my bottom equation is going to be 3x minus 15y is equal to 51. And so now what I'm able to do is subtract the two systems. And this is going to give me 3x minus 3x, which is 0. 2y minus negative 15y, which is going to give me a positive 17y. And then 0 minus 51, which is going to give me negative 51. So then I'm going to divide both sides by 17 to get y is equal to negative 3. Then I'm going to come back up to my original system, and I'm going to go ahead and plug that in for this answer for this equation right here. So I'm going to have x minus 5 times negative 3 is equal to 17. So I'm going to get x minus negative 15 is equal to 17. But remember, we can rewrite that as x plus positive 15. So we're going to go ahead and do that. And then we'll subtract 15 from both sides to get x is equal to 2. So then I'm going to write my ordered pair up here as 2, negative 3. So looking right here at number 7, we're going to have to do the same thing. And I'm going to go ahead and start with that x because it's got a coefficient of 1, so it's going to be the easiest to work with. And I'm going to multiply this whole equation right here by 2 because I've got this 2x right here. So my top line stays the same because I'm not doing anything to it. But my second equation is now going to become 2x plus 4y is equal to 10. And I'm going to subtract these. So 2x minus 2x is going to give me 0. 3y minus 4y is going to give me negative y. And 6 minus 10 is going to give me negative 4. So then, to get rid of this negative on the y, I'm going to divide by negative 1. And that is going to give me y is equal to positive 4. So then I'm going to go back up here to my original system, and I'm going to plug this in. So I'm going to get x plus 2 times 4 is equal to 5. So x plus 8 equals 5. And I'm going to subtract 8 from both sides to get that x by itself. And I'm going to get x is equal to negative 3. So coming back here, I'm going to write my ordered pair. So I've got an x of negative 3 and a y of 4. So that is my ordered pair. That is my answer for this question. On number 8, we're looking at options here because now I have an x with a coefficient of 1 and I have a y with a coefficient of 1. So I am going to use this top row, and I want this y with a coefficient of 1 to become a y with a coefficient of 2. So I'm going to multiply this whole thing by 2. So I'm going to get, I'm going to get 6x minus 2y is equal to 4. And then I have x plus 2y is equal to 3. So from here, since now I have this set of opposites, I'm going to add these together instead of subtracting, because remember I've got the opposites, so I can add them, to get 7x, negative 2y plus positive 2y will give me 0, and then 4 plus 3 is going to give me 7. So from here I'm going to divide, and I have an answer of x is equal to 1. And then I'm going to go ahead and use this bottom equation up here. So I'm going to have 1 plus 2y is equal to 3. I'm going to subtract 1 from both sides to get rid of my constant, and I'm going to have 2y is equal to 2. And then I'm going to divide by 2 on both sides to get y is equal to 1. So then I'm going to come up here and write my ordered pair for my answer. I'm going to have 1, 1, and I am done. Okay, we've got 2 more. So now we're looking at what happens when we don't really have nice numbers to work with, and we have to find something that we would find 2 numbers that share a common multiple. So looking at 4 and 6. I think that is going to be the easiest one for me because we know that 4 times 3 equals 12, and that 6 times 2 equals 12. So I can get a 12x in both equations. So that's what I'm going to do. So I'm going to go ahead and take this top one, and I'm going to have to multiply it by 3. And then I'm going to take the bottom, and I'm going to multiply it by 12. So rewriting that top row, or not 12, sorry. I'm going to multiply by 2. So to that top row, I'm going to get 12x plus 15y is equal to 18. And then on the bottom row, I'm going to get 12x minus 14y is equal to negative 40. So now I have 2 of the same term right here. So I'm going to subtract these 2 equations. And this is going to give me 12x minus 12x, which is 0. And then 15 minus negative 14y, which is going to give me 29y. And then 18 minus negative 40, which is going to give me a positive 58. So from here, I'm going to divide by 29 on both sides. And I'm going to get y is equal to 2. So then I'm going to use this top row right here. And I have 4x plus 5 times 2 is equal to 6. So 4x plus 10 equals 6. I'm going to subtract 10 on both sides to get rid of my constant. So I'm going to get 4x is equal to negative 4. And then I'm going to divide by 4 on both sides, which will give me x is equal to negative 1. So then I'm going to write my ordered pair up here, where I've got an x of negative 1 and a y of 2 to get the point negative 1, comma 2. All right, and last over here on number 10, I am given a nice little y with a coefficient of 1. So I need it to be a 2y. So I'm going to multiply this entire bottom equation by 2. So that top row is going to stay the same. 4x plus 2y is equal to 8. And then I'm going to get 32x minus 2y is equal to 28. And since I have positive 2y and negative 2y, and they are opposites, I am able to add those together. So I'm going to get 36x is equal to 36. And then I'm going to divide on both sides, which will give me x is equal to 1. And then I'm going to come up here to this top equation, and I'm going to go ahead and plug 1 in for x. So 4 times 1 plus 2y is equal to 8. So I'm going to get 4 plus 2y equals 8. I'm going to subtract 4 on both sides. And I'm going to get 2y is equal to 4. And then I'm going to divide both sides by 2 to get y is equal to 2. And then, of course, I'll write my ordered pair, which has an x of 1 and a y of 2, to get the point 1, comma 2 as my answer.